Hey guys, so today we are learning about the perpendicular bisector theorem. Basically what it states is that if a point lies on the perpendicular bisector of a segment, then it is equidistant from the points of the segment. So just to draw another kind of similar diagram, okay, if I create this segment, okay, and I draw a perpendicular bisector to the segment, okay, remember it is perpendicular, so it creates a right angle and it bisects that segment, so each side is congruent. Now if I draw a perpendicular bisector, okay, any point on that perpendicular bisector is going to be equidistant from either endpoint. So if I were to draw something, say, up here, if I were to make a point up here, okay, the distance from this point, oh dear, from this point to the end point here is going to be the same as the distance from this point to the end point here. Don't mind my terrible drawing skills. Okay, I have a kind of live action example for you guys. So here you can see that a perpendicular bisector was created, okay, and now we're going to check out points on the bisector, okay. Now notice there are points on the bisector that are above that segment, and as I move this point along the bisector, notice that these, not the distance here and here, okay, are always the same, okay, as I move that point, right? They're always the same because the point is on the perpendicular bisector. Same thing here. Since this point is on the perpendicular bisector, these will always be congruent, okay? Let's, for this argument's sake, find a point not on the bisector. Okay, this actually represents the converse of the perpendicular bisector theorem, where if it, well, not the converse, negation, but so if you see that you have, okay, two lines that aren't equivalent, this point here must not be on the perpendicular bisector. Now, if we move it, we can try to get it to the perpendicular bisector, but it's very temperamental. We came kind of close, okay? We came pretty close. However, you can tell by these two measurements, this point is not perfectly on that perpendicular bisector. If it was, those measurements would be exactly the same. Now, the converse of the perpendicular bisector states that if you know that these two lines are congruent, right? This line is congruent. Let me get the highlighter here. Okay. If you know that this line is congruent to this line, okay, then you can conclude, okay, that the point D lies on the perpendicular bisector, okay. In this diagram, it's not so easy to see because this line doesn't extend to point D. So the dead giveaway is that those two lines are congruent, okay? So that's the reverse. So the perpendicular bisector theorem is if a point lies on the perpendicular bisector, it's equidistant from the endpoints. The converse is opposite. If a point is equidistant from the endpoints, then it lies on the perpendicular bisector, okay? The angle bisector theorem, okay? So if we have this angle here, okay, right? And, okay, if a point lies on the bisector, so I know AD is the bisector, okay? And if D is actually on the bisector, okay, then it will be equidistant from the sides of the angle, okay? It will be equidistant, okay? And again, another live action version of that I have here with the angle bisector. So you have this angle EAF, okay, and this point D that is on the angle bisector, okay? Notice this, it's bisected because each angle is 21.98, okay? I know D lies on the perpendicular bisector because 2.24 is equal to 2.24, right? So check it out. As I move it, okay, it still stays equivalent because I'm moving it along that angle bisector. So they stay equivalent. All right, that's that angle bisector in action. And keep in mind, you might think it's a little odd to have that 90-degree symbol in the bottom right corner there. Okay, remember that the distance from a point to a line is measured always perpendicularly. So that's how I know that this is the correct distance from point D to line AF. And this is the correct distance from point D to line AE. Okay, and that they are the same. Okay, so again, the converse is the reverse. Okay, so in this case with the converse, I know that GB is congruent to DC, therefore AD must be the perpendicular bisector. Okay, it's a lot easier to put these words into actions. So it says find the indicated measure and explain your reasoning. Okay, so they want us to find the measure of AB. Okay, well, I know that BAD, is the perpendicular bisector of BC because it's perpendicular and because these two are congruent. Okay, so I know that AD is the perpendicular bisector of BC, therefore point A must be equidistant from endpoints B and C, making segment AB equivalent to 9. That segment thing. Shouldn't have that there. Oh no. Oh no. Kels, what'd you do? Oh gosh, you're all listening to me talk to myself. It's embarrassing. There we go. Okay, when you're giving the measurement of a segment, you really shouldn't have that line over it. So anyway, all right, we proved that it was the perpendicular bisector. Therefore, any point on it must be equidistant from the endpoints. So this must be 9. Okay. Moving on, all right, I know that HF is perpendicular to EG. I know that F is equidistant from the two endpoints, right? So I would write, and I'm going to do this one in a different color, F is equidistant from endpoints E and G. So HF must be the perpendicular bisector, making HG equal to 3. Okay, all right. The main part about the explanation is always explaining that, yes, I can prove that HF is the perpendicular bisector, okay, of EG. All right. Moving on to the last one. All right, we're getting a little tricky. So I'm going to skip the explanation part, okay, and we're just going to try to get the show on the road, okay? I know it's a perpendicular bisector because RU is perpendicular to ST. I also know that RU is the perpendicular bisector of ST because R is equidistant from both endpoints. Therefore, if ST is being bisected, 2x plus 2 has to equal 3x. So I can subtract 2x from both sides, and I'll be left with 2 is equal to x. Okay, but my question was not what is x. My question asked me to find the measurement of SU, which is represented by this equation. So I have to plug in my x into that equation. So 2 times 2 is 4, plus 2 makes SU, it makes SU equal to 6, which is exactly the answer we were looking for. Okay? Okay? So part 4, they want you to find the equation of the perpendicular bisector of AB. So this could get a little bit hairy, okay, but I need you to stay with me, okay? I'm hoping I'll have enough room to complete this, all right? So step 1, okay, is let's find the slope of AB. We have to find the slope of AB because that indicates what the slope of our perpendicular bisector is going to be. Okay, so let's go back and find the slope of AB. Okay, the slope of AB. Okay, AB, we're going up 1, 2, 3, 4. So our rise is 4 over our run, which is 1, 2. 4 over 2 gives me a slope of positive 2. I need to find the opposite reciprocal of that. So the opposite reciprocal of a slope of 2 gives me a slope of negative 1/2. Okay, so I know right away, all right, I know that my perpendicular bisector the equation of that line is going to be y is equal to negative 1/2 x. The only thing I don't know now at this point is my y-intercept, okay? So what I need to do, well, I've got the perpendicular part taken care of. I need to have the bisector part taken care of. So that means I have to use my midpoint formula to find the midpoint of AB. So point A is at 0, negative 2. Point B is at 2, 2. I need to find the midpoint of AB. So I'm going to use this here to find the midpoint of AB. Okay, midpoint formula, if you'll recall, is x1 plus x2 over 2. y1 plus y2 over 2. Okay, so I'm going to plug in what I know. So the midpoint of AB is equal to x1 is 0 plus x2 is 2 over 2, and y1 is negative 2 plus y2 is 2 over 2. Okay, which gives me a midpoint AB at 0 plus 2 is 2 over 2 is 1. Negative 2 plus 2 is 0 over 2 is 0. So I have a midpoint for AB at positive 1, 0. So this is my midpoint. This is the point that my perpendicular bisector must run through. okay? Now, rather than plugging it in and finding my y-intercept, right, that's the only thing that I'm missing at this point, I'm going to use my opposite reciprocal slope. So I'm going to go down 1 to the right 2, okay? Now, did that show me my y-intercept? No. But what it did show me is that I can continue it going up 1 to the left 2, okay? All right, and this now here is my straight line, okay? All right, now I can't really tell exactly where I'm crossing the y-axis here. So what I want to do is I know that my equation is right here, okay? I also know, I know my slope is -1/2. I know it has to run through this midpoint. So I'm going to use that information to make sure that my answer is accurate. I'm going to plug in y is equal to -1/2 x plus b, and I'm going to plug in this midpoint here. I'm going to say 0 is equal to -1/2 times 1 plus b. And that's going to come out to -1/2 plus b. I'm going to add 1/2 to both sides. Okay, and you get a b of +1/2. So plugging that into our equation here, my final answer is actually going to be y is equal to -1/2 x plus 1/2. Okay, that is the equation of my perpendicular line, which we found right here. Okay, I hope that wasn't too confusing for you, but basically the steps are to, number 1, okay, find the slope and use the opposite reciprocal. Number 2, find the midpoint. Number 3, plug the midpoint into your formula. So, a couple of questions about angle bisectors now. We did perpendicular bisectors at the top. Now we're talking angle bisectors. Okay, so here we're told that the distance from C to B is congruent to the distance from D to B is congruent to the distance from D to C, which means D must lie on the angle bisector. Okay, so if D lies on the angle bisector, then AD is the angle bisector. Meaning, if DAB is equal to 20, then the measure of angle CAD must also equal 20 degrees. Therefore, creating the angle CAB, okay, then the measure of angle CAB has to be these two angles added together, so it's got to be 40 degrees. Okay, over here, we're told by the measurements, where am I here? We're told by the angle measurements that AD is in fact the angle bisector of CAB. Okay, it bisected the angle, they're each 30. So when you know that this is the angle bisector, if this side's 5, if DB is 5, this side must also be 5. So DC must also equal 5. All right, and the last part, okay, again, we are told that we have a set of angle bisectors here and here. Okay, so the angle is being bisected, which means that the distance from the point on the angle bisector to the sides of the angle must be congruent. If they're congruent, it allows us to set them equal to each other. Okay, we can subtract 3x from both sides. You get 1 is equal to 2x minus 1. Add 1 to both sides. and you get 2 is equal to 2x. Divide by 2, and x must be equal to 1. Okay, now we are not done with our problem because they ask for the length of BD. So that is this side of the equation. So we need to plug 1 in for x. 3 times 1 is 3. So this is the measure of BD. 3 times 1 is 3 plus 1, right? 3 plus 1 is 4. So the measure of BD has to be equal to 4. All right? I hope this wasn't too much for you guys. I know number 4 probably seemed a little tricky. However, it's 3 steps. Find the slope and the opposite reciprocal of it. Find the midpoint. Plug it into this equation here, and you're done. Okay? So I'm hoping this went well for you guys and you had a good understanding of it. And we'll move on to 6.2 now.